Again, welcome back to calculus. We are going to continue with the functions and their graphs. Our main objective in these lectures is to learn how to sketch the graph of a function, also identify different types of transformations of functions. Also, we are going to learn how to classify functions and recognize combination of functions. So here we say a graph of a function y equal to f at s may consist of all points x and f at s, where x is the domain of a function. As shown in this diagram here, we have a graph of a function which is y equal to f at x, and all the points here are x and f at x, or we say s and y. As in our previous lectures, this is again two dimensions graph. We have only x and y, so each point may have x and y coordinate points. So here we say that x equal to the directed distance from the y-axis, and f at x will be the directly distance from what the x-axis. So we can see on the graph f at x section on the vertical y. I always say the y is the same as f at x. Then x will be the horizontal. Now, a vertical line can intersect the graph of a function of x at most once. This is what we call the function. So we normally have a vertical line test. We again vertical line test to check if a function or a graph is a function. It means the vertical line can only intersect the graph only once. So here we say this observation provides a convenient visual test called the vertical line test for a function of x, which is a vertical line can intersect the graph of a function of x at most once. So we have actually three graphs here, and we want to see if all these three graphs are a function. So we check the first one. We draw a vertical line. We see that a straight vertical line intersects twice on the graph. So this is not a function. Again, it's a graph, but it's not a function. That's all, again, we want to say here. Now, in the next question, we can see that the intersection is only once. So this means, again, it's a function. So B, a function of x, is a function. Now we can look at the third one, and the third one also we can see that it's a function of x. So that's the whole concept, a vertical line test to check if a graph is a function. At most, we have to have only one intersect. A vertical line can intersect a graph of a function of x at most once. Now, these are some few examples we have here. And this figure shows the graph of 6 basic functions. So this is, as we saw this, actually that's what we are doing right now, linear function. So this is what we call the identity function. F at s equal to x, a linear. Also, we have a squaring function. A squaring function means, again, now, if the x exponent is 1 of an equation, if we have equation, let's say y equal to x plus 7, it will be, if we graph it, it will be a linear. Now, if it's x squared plus 7, then it will be a parabola. So that's why quadratic equations, their graph look at this form, either open upward or open downward. And we shall also cover that in the future. Also, we have a cubic function. This is a function. And also square root function. And we have absolute value function. We know absolute value, whether it's positive 1 is 1, negative 1 is 1. So that's why it's like a mirror image of the negative area and the positive area. Then we also have a rational function. So these are, I would say, the basic 6 different functions we will see a lot in college algebra. Now, next is the transformation of functions. Now, a function can shift upward, right, left, or if we have a parabola, it can open upward or it can open downward. So let's see the difference here. Now, we can see here we have a function y equal to x squared. So it's a parabola. And since it's x squared, the original point 0, 0. But here is plus 2, x squared plus 2. So it will move upward twice. Now here we have a function y equal to x squared again. But this time we say y equal to x plus 2 all squared. We square everything. Here we still have y equal to x squared plus 2. So it shifts upward. Now here we have x plus 2 all square. So this will shift again to the left twice. And so this is transformation of a function. Again, we have y equal to x squared. This time we have y equal to 1 minus x plus 3 all square. So we can see the transformation. Or y equal to x squared and y equal to... Now, this is quadratic equation. When the x squared coefficient is positive, it will open upward. And when it's negative, it will open downward. So this is just a few examples of, again, transformation of a function. We will see an example soon. So we say that again, each of the graphs in the previous slide is a transformation of a graph of y equal to x squared. We saw y equal to x squared plus 2 or x plus 2 all square, etc. You see how the movement is. So for instance, using f at s equal to x squared, we saw that y equal to f at s plus 2, vertical shift 2 units up. We saw that. And also y equal to f at x plus 2, we saw the horizontal shift to the left 2 units. Also, negative f at x, the reflection about the x-axis, either it open upward or downward. Then we also saw the last one, y equal to minus f, s plus 3 plus 1. Now, let's go back to the graph again. So this is what we are trying to explain here. So we saw the y equal to x squared plus 2, it shifts upward twice. Y equal to x squared, by this time y equal to s plus 2 all square, it will shift to the left twice. Okay, so the basic types of transformations, here we say c should be greater than 0 or constant value. Here, so c is a constant value. So horizontal shift c unit to the right. Now in our previous question, we saw y equal to x squared, or y equal to f at x, f at s squared. Now we also saw that this time instead of saying y equal to s squared, we say y equal to s plus 2 all square. So we can see the plus and minus, how it works. When it's minus constant value, let's say 2, 3, any value, the horizontal shift to the right. In our example, we saw that the constant value was plus 2. So it shifts to the left, minus 2. So left. Now we also see f at s minus 6. This will shift downward. Plus 6, we saw the plus 2 shift upward. And the reflection, whether it open downward or open upward. So let's go back to the equation, what we are trying to say here. This is the graph again. Y equal to s squared. Now y equal to s squared plus 2 will shift upward. Now if it's y equal to s squared minus 2, it will shift downward twice. Same thing here, we have s plus 2 all square. If it's s minus 2 all square, it will shift to the right twice. And that's what we mean here. Minus c, or let's say minus 2, shift to the right 2 times. So that will be the conclusion of this lecture. So in this lecture, we just learned the basic concept again on how to sketch a graph of a function and also different types of transformation of functions. So again, see you in the next lectures, and thank you for your time.